Okay, so in this video I'm going over the 3.1 to 3.4 quiz review. The first question wants me to identify the vertex of y equals 2x squared minus 4x plus 3 by converting to vertex form. So on this I want to complete this square. I'm going to start off by factoring out a 2 from my first two terms, and the reason I'm factoring out a 2 is because this is my leading coefficient, and I always want to make that 1. So I'm going to have 2 times x squared minus 2x, and then I'm going to leave that 3 alone at the end for now. Then what I want to do is I want to take half of my remaining b value, so half of negative 2, and I am going to square that and add it at the end of the stuff inside the parentheses. So the negative 1 came from half of 2. Then I still have this 3 on the outside, but I also, because I need to keep this equation equal, I need to cancel out this negative 1 squared that I just added. It's being multiplied by a positive 2, so I want to start by multiplying by a negative 2 to cancel it out, and then I'm also going to multiply by that negative 1 squared that I need to get rid of. So then what I want to do is I want to simplify that 1 squared, negative 1 squared. So negative 2 times negative 1 squared is, negative 1 squared is 1, times negative 2 is negative 2. So that's where this negative 2 came from. Then I want to factor the stuff inside the parentheses. So that's going to come out to x minus 1 squared. And then I want to add the numbers on the outside. 3 minus 2 gives me positive 1. So now this is in vertex form. Remember, for my vertex, I always switch the sign of the number with x, so it's going to be positive 1. And the sign of the number outside stays the same. So it's 1, 1. Number 2 wants me to identify the x-intercepts of this graph. It doesn't tell me what method to use, so I am going to go ahead and graph this on my calculator. I'm going to type it in. I have x squared minus 4x minus 12. And I want to go graph it. Ooh, I want to fix my window. Okay, now that I've fixed my window, I want to figure out what these two zeros are. I'm going to go second trace, go to 0, arrow over to the left side, press enter, arrow over and cross that the x-axis, and then press enter twice. I get x equals negative 2. Then I'm going to do the same thing for the other one. So this time my left side is below the x-axis. I want to go ahead and press enter. Then I want to cross that x-axis, press enter twice, and this 0 is x equals 6. And that's just my answers for number 2. Number 3 wants me to use the leading coefficient test to describe the left-hand and right-hand behavior of this equation. So it is positive, and I can tell that by looking at my leading coefficient. So it's a positive 4, and it's an odd exponent, so it's going to look kind of like this. So on the left side, it is falling. So on the right, falls on the left. And then on the right side, it's going up. So on the right, rises on the right. Number 4 wants me to use long division to solve this polynomial divided by x minus 3. So long division is the one that is written like this. I have x cubed minus 2x squared. I don't have an x term originally, so I'm going to add 0x as a placeholder, and then minus 4. And then what I want to do is I want to look for what multiplies to negative 3 and turns into x cubed. This is x squared. I'm going to do my work down here. So I'm going to do x squared times the x minus 3, which if I distribute will give me x cubed minus 3x squared. So then I want to go up above and write this out under those matching terms. Then I want to go ahead and subtract these out, so I change both of those signs to subtract it out. And I also want to write what I got, which was x squared, above the matching term. So right up above here. My x cubes cancel out. Negative 2x squared plus 3x squared just gives me x squared. And then I'm going to bring these last two terms down. So I have plus 0x minus 4. Then I want to turn x into x squared. This needs to be multiplied by x. So I'm going to take x and multiply by my entire dividend. I want to distribute x times x is x squared. X times negative 3 is negative 3x. So I'm going to write this under here. And then I'm going to write what I multiplied up above. It was a positive x, so I'm going to have a plus sign over here. Then I want to go ahead and subtract out. Let me draw my bar. So I'm going to change the signs here. The x squareds cancel out. I'm left with the 3x minus 4. So I'm looking for what I need to multiply x by to turn it into 3x. This is just 3. So I'm going to go ahead and distribute. 3 times x is 3x. 3 times negative 3 is negative 9. So I'm going to write this under here and write what I multiplied by up above. I'm going to change my signs. My 3x's cancel out. Negative 4 plus 9 is 5. So I have a remainder here. The way I write my answer is I'm going to write what I got on top of the division sign. So the x squared plus x plus 3. And then I'm going to add, no matter what it is, because sometimes if I have negatives, it only applies to the first number if there's multiple terms in my remainder. So I'm going to have 5 on the top, and then x minus 3, the thing I was dividing by on the bottom. So this 5 came from right here, and the x minus 3 came from what I was dividing by. And then this whole first part came from my top of the above. Okay, number 5 wants me to use synthetic division. So this one, I want to write all of my coefficients out for all of my terms in the L shape. I have an x to the 4th. I don't have an x cubed. I don't have an x squared. I have an x, and I have a constant. Then when I'm dividing by x minus 4, I want to take this x minus 4 and set equal to 0, and then solve, which gets me 4. So I want to write the 4 on the outside. For synthetic division, I bring down the 1, then I multiply by that 4. 0 plus 4 is 4. 4 times 4, the number on the outside, is 16. 0 plus 16 is 16. 16 times 4 is 64. Negative 3 plus 64 is 61. 4 times 61, I can't do this in my head anymore. 244. Then I want to add to that 5, which gives me 249. So then I just want to put back in my variables. My original variable went cubed. So now I want to go down an exponent. So, my original term went to the 4th. So I want to go down to cubed. So my leading coefficient here is 1. So I'm going to keep no number up front. Then I'm going to put the next term gets a 4 from right here. My next term gets a 16. My next one gets a 61. I'm at my constant, but I still have more numbers. So this is a remainder. So I'm going to have plus 249 divided by x minus 4. And then this is my final answer. Okay, number 6, it wants me to use the remainder theorem to evaluate this equation for x equals 3. So when I use the remainder theorem, I'm using synthetic division. I'm going to have a 3 on the outside. And then I'm going to write my coefficients of what I'm dividing, or my function on the inside. So I have 1 for my x cubed term, negative 12 for my x squared term, 0 for my x term, and negative 42 for my constant. Then I want to go ahead and drop down the 1. I'm going to take 3 times 1, which gives me 3. Negative 12 plus 3 is negative 9. 3 times negative 9 is negative 27. I drop down that negative 27. Negative 27 times 3 is positive 81. And then I'm going to add on the calculator because I know I'm going to mess this up. Negative 42 plus 81 gives me 39. So on the remainder theorem, the answer I get from my remainder is my answer. So 39 is my answer to number 6. Okay. Number 7 wants me to list every possible rational zero for this function. So I want to start off by finding my factors of p, which is my end value, the negative 2. It's always plus and minus. I have positive 1 and positive 2 for my factors of 2. Nothing else multiplies to 2. Then I want to find my factors of q, which are my leading coefficient. this is positive and negative 1, and positive and negative 3. Nothing else multiplies to 3. Then what I want to do for my possible rational zeros is I take all my values of p and divide by all my values of q. So all of these two values divided by positive and negative 1 will give me back positive and negative 1, positive and negative 2. Then I want to go ahead and take those two values and divide by positive and negative 3. So it's going to give me positive and negative 1/3, and then positive and negative 2/3. So these right here are all of my possible rational zeros. On number 8, it wants me to factor the polynomial to linear factors, and it gives me a 0. So I'm going to start off by using synthetic division. 2 is the number on the outside, and my coefficients are 1, 4, negative 13, negative 28, and 60. So when I bring down this 1, 2 times 1 is 2, 4 plus 2 is 6, 2 times 6 is 12, negative 13 plus 12 is negative 1, 2 times negative 1 is negative 2, negative 28 minus 2 is negative 30, negative 30 times 2 is negative 60, which gives me a remainder of 0, which is good, because factors, always should give me a remainder of 0. So what I want to do here is I want to go back and put this into a polynomial and then figure out my possible rational zeros and then test those. So I'm going to have x cubed plus 6x squared minus x minus 30. So my possible factors of p are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 5, plus and minus 6. 5 times 6 is 30. 3 and 10 go together. 15. And my last one is 30. Then I want to find my factors of 1, which are just 1. Q is mine. So my values for p divided by q are the same ones I just wrote up for p. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. Then I want to go ahead and test some of these values. I'm going to start with my 1 since they're the smallest numbers. So my coefficients are 1, 6, negative 1, negative 30. I bring down that 1. 1 times 1 is 1. 6 plus 1 is 7. 7 times 1 is 7. Negative 1 plus 7 is 6. 6 times 1 is 6. This gives me negative 24, not a factor. So then I'm going to try negative 1. Bring down that 1. 1 times negative 1 is negative 1. 6 minus 1 is 5. Negative 1 times 5 is negative 5. Negative 1 minus 5 is negative 6. Negative 6 times negative 1 is positive 6. Gives me 24. Still not right. I am going to grab another sheet of paper and then continue my testing. So I am doing 1, 6, negative 1, negative 30. I'm going to try 2 next. So I'm going to bring down that 1. 1 times 2 is 2. 6 times 6 plus 2 is 8. 2 times 8 is 16. Negative 1 plus 16 is 15. 2 times 15 is 30. Negative 30 plus 30 is 0. So this one works. I am going to then go ahead and rewrite this as a polynomial. Now it's squared. I can factor this by looking at the end. I'm looking for what multiplies to 15 and adds to 8. This is positive 3 and positive 5. then I need to write back all of my factors that I found that worked. So this 2 worked. Remember, I changed the sign, so it's going to be x minus 2. And if I looked at the very first one that worked, it also was a 2. So I want to have 2 x minus 2's in my final answer.